In Lesson 14, we're going to be looking at the least common multiple. The least common multiple of two non-zero numbers, A and B, written the LCM, so least common multiple is LCM, is the least whole number larger than 0. That's important. 0 is a multiple of every number, which is a multiple of both A and B. So kind of a crazy worded definition. We're going to see what it looks like. So we do have two ways that we're going to look at today. I'm going to lead you towards the latter method again, but we will see how both work. So if we want to find the least common multiple of 12 and 18, we're going to start with the list method. We are going to list out all of the multiples of both of these numbers. To find a multiple, you start multiplying with 12 as a factor, and you do it in numerical order. So I would always start with 0. So 12 times 0 is 0. 18 times 0 is 0. Now notice it has to be larger than 0 by definition. So a lot of times we just leave off the 0 from the list knowing that it's there, but we don't want to get it confused as our least common multiple. With factors, we're looking for the greatest one they have in common. With multiples, we're looking for the least one they have in common, except for 0. So I'm just going to kind of put a line through that to show that's not it. Now I'm just going to go in order. I just multiplied by 0. I'm going to multiply by 1. So 12 times 1 is 12. 18 times 1 is 18. These are not in common, so I don't have a common multiple yet. The next thing I'm going to do is multiply by 2. So 12 times 2 is 24. I'm going to do 18 times 2, which is 36. Still nothing in common yet. As I move on, though, 12 times 3 is 36. I've found my least common multiple. Okay, so that's how you do it with the list method. Again, you have to be good with your multiplication there. For the ladder, it's the same exact setup and ladder as with the GCF. So you can pick any number that goes into both of them. Let's say I start with 2. 2 can go into 12 6 times. 2 can go into 18 9 times. 6 and 9 can both be divided by 3. 3 goes into 6 2 times. 3 goes into 9 3 times. No common factor here besides 1, so I'm done. Now, with GCF, we only looked at the numbers down the side. With LCM, we're going to look at the numbers down the side and across the bottom. Notice it makes the letter L for LCM. We are going to multiply all of the numbers across this line. So 2 times 3 times 2 times 3. I like to break it up. So I know 2 times 3 is 6, 2 times 3 is 6, and 6 times 6 is 36. Okay, so there's the method. For ladder method, it's kind of easier because you can pull your GCF and your LCM out with the same work. Whereas with the list method, you'd have to have all different lists going on for factors and multiples. So once again, I'm going to lead you towards that ladder method just because I find it to be a little easier for students to catch on to. Okay, so for example 2, for 14 and 21, I'm going to do the ladder method. These I can see both being divided by 7. 7 goes into 14 2 times. 7 goes into 21 3 times. 2 and 3 don't have a common factor. So I'm going to do my least common multiple, 7 times 2 times 3. I'm going to break it down a little differently and do it this way to get 42. Remember with multiplication there's a commutative property, so it doesn't matter which order you multiply them, and that's why I picked out that 2 times 3 first. Okay, so that would be my LCM for 14 and 21. Now example 3 is going to be the 3 number method, and it's a little different with the ladder method, so I want to show you that. So if I'm finding the GCF, it's the same process we did yesterday, and this one's asking us to find both GCF and LCM. I'm going to look for a number that can go into all 3 of these, which would be 2. 2 goes into 6 3 times, 2 goes into 8 4 times, 2 goes into 12 6 times. At this point, all 3 of these numbers do not have a common factor, so I would stop right now for my GCF. My GCF is the numbers down the side multiplied together, but there's only one, so it's 2. However, for LCM, I can keep going. So pull out your GCF once the three bottom numbers don't have all three of them with a common factor. But for LCM, we actually continue on. If any two of the numbers across the bottom here have a common factor, you move on. So there are actually a couple of different ways to move on from this one. I'm going to look here at the 3 and the 6 first. They can both be divided by 3. So what I do in this case is I put the 3 out here. I divide it into the numbers it can divide into. So 3 goes into 3 one time. 3 does not go into 4 at this point, but I'm going to bring down that 4. And then 3 goes into 6 2 times. I continue on in that same method. So at this point, 2 and 4 can both be divided by 2. I just bring down the 1 since 2 can't go into it. 2 goes into 4 2 times, and 2 goes into 2 one time. Nothing here can be divided except by 1. So at this point, I would do my 2 times 3 times 2 times 2. I just take out the 1s because they're just going to bring me back. And then I multiply and get my LCM that way. Okay, there was another way we could have done this. So I started off with the 2, the 3, the 4, the 6. At this point, I could have also saw that 4 and 6 can be divided by 2. So notice I'm just changing the order here. 2 doesn't go into 3, so I bring it down. 2 goes into 4 twice, and 2 goes into 6 3 times. At this point, 3 and 3 can both be divided by 3. 3 goes into 3 once, it doesn't go into 2, so the 2 comes down, and 3 goes into 3 one time. Still the same exact numbers. We have 2 2s down the side and a 3, and then the 1 2 1 across the bottom. So we'll still get the same result either way we do it. Okay, so then we have some word problem examples. This says bus A returns to the station every 14 minutes. Bus B returns to the station every 12 minutes. If both buses just left the station, how many minutes will it be until they are both at the station together again? How many times will bus A have returned in that time? How many times will bus B have returned in that time? When you have a problem like this happens this often, this happens this often, how long will it be until it happens together again? This is a typical LCM problem. So with this type of typical LCM problem, we are going to be taking the amount of time for bus A and the amount of time for bus B and finding the LCM of them. So 2 can go into both 14 and 12. 2 goes into 14 7 times and into 12 6 times. So nothing else can go into 7 and 6 except for 1. So we'll find our LCM by doing 2 times 7 times 6. I'm going to just break it down and do it this way. When I multiply these together, I get 84 minutes. Okay, so that would be in how long it will be until they are both at the station together again. So again, remember, anytime you see a problem that says this happens this often, this happens this often, how long will it be till they happen together again? That's LCM. Now, it's asking how many times will bus A have returned in that time. So we're going to take the 84, so this is bus A. Take the 84 and divide it by the 14 minutes that it takes for bus A to return, excuse me, and we will get 6. And notice this is bus A, this is bus B. 14 is here. Underneath it is 7. That's not the answer we get here. It's actually the diagonal for LCM, not directly underneath like it is for GCF. So then for bus B, we would take the 84 and divide it by the 12 minutes, and this would give us the 7. So again, you can use your division by taking your LCM and dividing it by each one, or you can use the diagonal number underneath. Just be careful that you're not doing the one directly underneath, because that's where students tend to make the biggest mistakes. Okay, so that's the end of that. There are also other LCM word problems very similar to the way the greatest common factor has word problems, where it says what is the greatest number of this you can make. With least common multiple, it will say something along the lines of what is the least number you can make, or the smallest, anything meaning least. So two different types of LCM word problems. One where it's this happens this often, that happens that often, how long till they happen together again, or what is the least amount of whatever it is you're looking for.